Hi and welcome back. This is Hector at HelpMeGraduate.com with math tutorial videos. We're doing derivatives, and so far we have done derivative of exponents, products, constants, divisions, chain rule. Basically, pretty much covered every single topic. Well, we still have a few more topics to go. But there's one particular topic that isn't mentioned in most books, especially in most textbooks, like simple college textbooks. Not saying that they're bad or anything. It's just that they stick to the protocol too much. Is a particular topic that I personally like to call alternative methods to find derivative. Okay, they're OTB. You know what OTB stands for, right? Out of the box methods. Okay, it's just different ways of seeing problems and confronting them with the methods that and tools that you have learned from before, from the past. Okay, and you're gonna get you're gonna like what you're going to see, what I'm going to show to you. One thing I have to warn you though, okay, before using these methods in any exams or assignments, homeworks that you may have, you may want to double check with your professor and see if he agrees with you thinking out of the box and using these alternative methods, okay? Because sometimes not everyone likes to move out of the protocol. Sometimes professors want you to learn and use certain rules, like if you have the derivative of a product, and then he's just going to want you to learn the process of finding derivative following the product rule, okay? And if you use something that is a little bit more away from the protocol, okay, you may get a little bit less grade, and we don't want that for you, okay? The alternative methods are for two things. First of all, expanding your mind, you know, just thinking of math like I've always said. There are many paths to get the same goal, okay? And number two, just, you know, getting the grip of math and loving things and seeing how sometimes thinking out of the box can be productive, can be workful, okay? On the other hand, there may be professors who may be complimenting you for using these alternative out-of-the-box methods, okay? And one of them is going to be involving logarithmic properties that you have here signaled on the right side of the board, okay? We're going to use these four properties. Some of them we have seen in past videos. Some of them you may be seeing for the first time. If you want more information, you can go check the past videos of logarithmic functions, okay? The first property, as you may know, is the logarithmic of a product is equal to the logarithmic of the addition of each element separated, okay? The second property is the logarithmic of a power to b is equal to b multiplied by logarithmic of a, okay, natural logarithm. The third one is logarithmic of a natural logarithm of the division a over b is equal to the subtraction of a minus logarithmic of b, okay? And the third one, chain rule that we have seen in past videos, derivative of logarithmic of f of x, is equal to f prime x over fx, okay? It's the internal derivative of chain rule and logarithmic, okay? Just the fx goes down, 1 over that, multiplied by the internal derivative. That's why I have it written in blue, okay? So, the first example that we're going to see at first looks like a very basic simple multiplication example, okay? Y equals x plus 1 times, or multiplied by, 2x plus 1 multiplied by 3x plus 1, okay? Like I said before, there are many methods, many ways that you can solve this, okay? You can, first of all, multiply every single element in the equation, and then you'll have this big polynomial, and then all you have to do is find the derivative of that polynomial. It's going to take you a few lines of code and notebook, but it's a method. The second method that you may actually be thinking of the first time that you saw this is, well, but isn't this a multiplication? Can't we just use the product of the rule of derivative of a product? Well, yeah, sure, we can do that, you know, derivative of the first and second without, but then which one is the second? Well, maybe let's do this two and these two, or maybe let's do these two instead, you know, it gets a little bit confusing. Or, the third method, we can use the alternative out of the box method, which I'm going to show you right here. So, this function relates to one of these properties. Which one do you think it relates to? If you said the first one, that is correct. We're going to have a product of three elements right here. Element A, element B, and element C. And as you may have imagined, I can just make a little tweak on the first property and say something like the logarithmic of A times B times C equals logarithmic of A plus natural logarithmic of B plus natural of C. Okay? This is what I'm going to use to solve this. Okay? Take a few seconds, take a look at it, because I'm going to erase it only for space to have more organized in space in the board. Okay? Got it? Logarithmic of A times B times C equals logarithmic of A, logarithmic of B, and logarithmic of C. Okay? So what I'm going to do is something very easy. Do you remember the limits video where we multiplied by the conjugated, which is multiplied in essence by 1, or remember the video on limits that we added and subtracted 1 to the numerator of the fraction? Well, we're going to do something exactly like that. I'm going to apply natural logarithmic to both sides of the equality. Okay? So on the left side, I'm going to have logarithmic of y. Okay? But if I apply logarithmic of y to the left side, I have to do it to the right side as well. So I'm going to have logarithmic of x plus 1, 2x plus 1, 3x plus 1. There you go. Okay? How does that help? Don't panic. We're getting there. What I'm going to do next is simply use derivatives and the property. Okay? They're asking me to find y prime, the derivative of this function. So, in essence, what they're asking me is this. Prime this, and prime this. Right? So, here comes the beautiful part. On the left side, logarithmic natural y prime that is nothing else but 1 over natural logarithmic of y times the internal derivative, which is derivative of y prime. Remember that the argument of the function is x. It's not y. So the derivative of y is y prime. That is what the problem is asking. Okay? That's the trick and the beauty of the out-of-the-box method. Okay? The variable is x. It's not y. Okay? On the right side, what am I going to have? Well, I'm going to do a preview, and then you will see what is going to happen. Okay? Let's do the preview in blue. Okay? Blue color. The derivative of all this is equal to do the derivative of this. Plus natural logarithmic of 2x plus 1 plus natural logarithmic of 3x plus 1 prime. And there we go. Okay? Oh, I'm sorry. This is why. Because the derivative of logarithmic of y is 1 over 1. Okay? This property right here. So, how does this work out? All I have to do is do 1 over this, 1 over this, 1 over this, times the internal derivative. So what we're going to do is do 1 by 1. Derivative of logarithmic of x plus 1 is going to be 1 over x plus 1 times the internal derivative, which is the derivative of this, which is 1, because x derivative is 1 and 1 is 0, plus this 1 over 2x plus 1 times the internal derivative, which is 2, plus 1 over 3x plus 1. Multiplied by the internal derivative, which is 3. 3x derivative is 3. And there you go. Is there something else missing? Yeah. We have to leave the y prime alone, which is what they're asking us for. Okay? And all we're going to do is simply take this y and move it all the way here. And we will be done, and that's it. So let's do it real quick. Y prime equals 1 over x plus 1 plus 2 over 2x plus 1 plus 3 over 3x plus 1 multiplied by y, because y is all the way in the multiplication part. And what is y? Well, we have it right here at the beginning. X plus 1 times 2x plus 1 times 3x plus 1. And there you go. That is the solution of the exercise. See how long it took? 1, 2 lines. And the third one is the solution. It's just an out-of-the-box method. Let's recapitulate one more time, okay? We have y, which is a product of 3 elements, okay? We're doing the out-of-the-box method. What we do is apply natural logarithmic to both sides of the equality, so then we have logarithmic of y, and then logarithmic of this, prime, because they're asking us for the derivative of the function, the y prime equals derivative of this is 1 over y multiplied by the internal derivative, y prime equals each one added individually because of the first property. Simplify and pass the y to the right side, and there you go. Voila. It looks like this method for this particular example is not really attractive, you know, because you may say, well, it looks a little bit annoying. Why don't I just simply multiply everything and just do the exponent? Well, you may be right, but as the functions become more complicated, the method will become more effective. And you will see that in the following video.